Okay, Mrs. Stanley here. We're looking at the unit circle. First, look at the diagram here on the left. You've got a circle put over the x and y axis with the center at 0, 0. Reading this description here, a unit circle is a circle with a radius of 1 unit. So the radius each time, no matter where you are on the circle, that measurement is 1, okay? Now imagine you're looking at this right triangle that we have right here. The hypotenuse is what equals 1, right? So here we go. Because the value of r is 1 for each point p of xy, sorry, the point p, xy is like the x and y value on the circle, the trigonometric functions of theta are defined as, so here's what we need to know. We have x and y as our two distances, okay? So sine of theta is always going to be equal to y, because think about it, theta is the angle here at the bottom near the origin, and y would be the opposite side, and sine is opposite over hypotenuse. Y over 1 just equals y. And then the cosecant is going to be 1 over y. The cosine, if you think about it, that's the adjacent, which in this case is x, over the hypotenuse, which is 1, so it's just x. Secant is just the opposite, 1 over x. And then tangent is the same, y over x, and cotangent is the opposite, x over y. We can write a point. The coordinates of P can be written as cosine theta, sine theta, because cosine is the x value. Now keep in mind, this is only on the unit circle. It's called a unit circle because it has a radius of 1 unit. Every point on the circle is 1 unit from the center or the origin. Okay, so it's cosine theta, sine theta for each point. One thing that you definitely want to memorize is that sine is y, cosine is x. Okay, so here we go. The unit circle is frequently used to map 30, 45, 60 degrees and their multiples, as well as 0, which is the same as 360, 90 degrees, 180, and 270, the quadrantal angles. Remember, we just talked about that word. So you can see this little map over here in the corner. We get exact values for each one of these angles. And what's the nice thing is that you start to notice that at 60 degrees, it's the same and it rotates around the circle. Like you'll see how these all rotate. So you end up getting the same value in different quadrants, you just get a different sign. And this is what I was saying ends up being easier because people just sort of memorize which quadrants are positive or negative for each function. And if you, once you memorize the first quadrant, you can just kind of transfer it around the circle. So here is what we need to do. You're going to have a page like this that you can fill in. It's a bigger full page circle and it's got blanks for you to fill in all the different values. And it's right here, complete the unit circle reference page. So I would encourage you to pause the video, complete the unit circle reference page, and then come back here and use your unit circle reference page to get the correct values. Okay, hopefully that you paused and you are ready and you have filled out your unit circle reference page. It looks like this circle right here on the right side of my screen, except you would have filled in, for example, pi over 6 is square root of 3 over 2 and 1/2. And so you would have these points labeled going all the way around, and you'll see why that will be helpful. On number 11, it says sine of 135 degrees. So we go to 135 degrees, and you find this value for sine, remembering that sine is the y value. So you need to know the y value at 135 degrees, and that is square root of 2 over 2. Another good thing that you can remember is sine is positive in quadrant 1 and 2, so we knew this answer has to be positive. Going to number 12, secant of 180 degrees. 180 degrees is right here, and you would have had the point -1, 0. Remember, secant is the opposite of cosine. Well, if the cosine is negative 1. Negative 1 over 1, when we flip it over, 1 over negative 1, what do we get? Our answer is still just negative 1, okay? Cotangent of negative 300 degrees, we've got negative 300, oh, no, I went to positive 300. Negative 300 degrees means that we're going to go around the circle like this, okay? So if this is 300 degrees, negative 300 is up here at basically the same thing, 60 degrees. And so what's our answer going to be? It's the cotangent. Now we know that the tangent of negative 300 degrees is going to be the y over x. In this case, we just need x over y. So you can do it, it's no problem. So we need to know what is that value at negative 300 degrees. So at negative 300 degrees, this point is 1/2 and square root of 3 over 2. So for cotangent, it's x over y. So 1/2 over square root of 3 over 2, and we need to simplify this. And I think we just did a similar problem on another one. So we get 1 over square root of 3, which we know that we have to simplify, and we get square root of 3 over 3. And we're in quadrant 1, and all of the functions are positive in quadrant 1. So I am going to let you try to continue this on your own and then check your answers. If you're getting stuck, I will tell you that this is a very important piece of information. It's a reference or a tool that we will use a lot. And I just realized all the ones that I did were angles, so let me go ahead and jump down to number 17 and at least do 1 or 2 of these with radians. It's the exact same thing. For example, number 17 says cosine of 3 pi over 4. If we go back to the diagram, you will notice that, what did it say, 3 pi over 4? 3 pi over 4 is right here. It's the same as 135 degrees, which may or may not be useful, but we know that the value of x and y is square root of 2 over 2, but x is negative. So here, cosine of 3 pi over 4, that's going to be negative because it's in quadrant 2, and it's going to be square root of 2 over 2 because that's the x value at 3 pi over 4. Okay? So for each of these, like secant of negative pi over 4, negative pi over 4 is going to be coming down here. Think about that. You're going pi over 4 distance from 2 pi. That's the same thing as 7 pi over 4. And so then we can say, look at our unit circle and say, okay, what's the value there? It's square root of 2 over 2 and negative square root of 2 over 2. And since I am doing secant, that is the opposite of cosine, so it's going to be 1 over x. And so this is the 4th quadrant, so I know it's going to be positive. And so it's 2 over square root of 2, which means I then need to multiply out and get just square root of 2. Right? So this does take a lot of practice, and it's really important that you give it a good effort. So go ahead and finish these up, and then you can continue on.